It's just like when you call up into a call center and you say, "Hey, how you doing? Can I check that flight?" And they're like, "Please hold." And then you say, "Okay, I'm just gonna hold. I'm just gonna sit here listening to the hold music." And they're like, "You know what? I don't think it's the network. I just don't exactly know how to prove it." But we bring up Wireshark and we see these black lines with these red letters, and we're like, "Oh no, the sky's falling. The network's being ripped apart at the seams." So let's actually see what's really going on.
Hey everyone, it's David Bombal back with Chris. Chris, you've got a really interesting topic to talk about today.
I do. At least I think it is. And that's how to filter traffic with Wireshark.
Yeah, it's a problem, isn't it? Because you've got we spoke about it last time, you've got all this traffic and how do you find stuff? So I think if I remember correctly, you're going to show us about Wireshark filters. Is that right?
Absolutely. So that's really a big topic that we have to, especially being Wireshark users, troubleshooters. It's super easy to end up with this mountain, this huge, huge haystack full of packets, and we got to dig in and find the needle. So the faster we can get to that needle, the faster we're going to be able to resolve problems, find cybersecurity issues, all the above. And filters are a big part of that.
Yeah, so take it away, Chris. Show us what you've got.
Okay, so what I'd like to do, David, I'm going to show you a few filters that not only do I use in my consulting practice, these are just common filters that I like to use, but also ones I like to make sure people are aware of. Sometimes you might go, "Oh, I didn't know I could filter that way. That's awesome," right? So these are things that I've picked up from other analysts or just found out by tinkering on my own. Really something that I've found too in my training classes, also on my YouTube channel, is just teaching people how to build those filters and remember them. Because let's face it, sometimes the syntax can be difficult to remember, right? Like, what was that? Was it IP.adder. Or whatever? Like, how do I build that filter? That's what I want to talk about today, just some common ones that people use. So I think—
Yeah, I've had a lot of feedback on our videos where people have said, they didn't know how to, that they could drag, like filtering as an example. They didn't know some of the filters that you were showing last time. So yeah, looking forward to this.
Yeah, awesome. Okay. Well, good. You can see my screen all right?
Yep.
Okay, fantastic. So the first thing I'm going to do is just set a regular IP filter, but we're going to talk about it too. So how do we do that, everybody? How do we set just a standard IP filter? If I just want to filter in on a single machine, let's just pick this address right here, 192.168. I want everything coming and going to that guy. All right, so let's go up. We're just going to do IP.adder. If I wanted that station to be the source, okay, SRC, source. If I want it to be the destination, DST. But in this case, I want it to be either one. I don't care if it's going to or coming from that station. Go ahead and show it, IP.adder. And now we can just do 192.168. Okay, so boom, I got my filter. And down here on the lower left, I take a look at my number of displayed packets and I can see that my filter worked. I have some things that matched it. And now I can start to do a little bit more tinkering. So that's just a common filter. That's standard. You're going to use that all the time. Let's go ahead and progress.
Why do they have two equal signs? Is there a reason for that?
So it's the standard syntax of the way that Wireshark's going to be doing its equals. You can actually have 3 equals there, and that means something slightly different. I don't think I've ever used that one. You can also have things like, okay, IP address does not equal. This is where we could come in and we can put an exclamation point in there. We could also, with some of the other filters I'm going to show you, we can also use a greater than symbol, a less than symbol. So really just depending on the type of filter that we're looking at, we always need to first give Wireshark, we need to tell it what field are we focusing in on, and then do I want that field to equal something, to not equal something, or to give it a range. This first one, what I like to do, so I really do start off with that. Let's just take an IP address and just see where we can go from there. So 192.168.10. All right, so from there, now I go, okay, I've got the address, but now maybe I want to fine tune that a little bit and start thinking about like a protocol or a port number. Well, once I have the address, then I can come here and I can just say ampersand, ampersand. See that, or I can use the English word and, right there. Either one will allow me to then make an addition to this filter. Now I can start to go, okay, how about, I can see it right here, TFTP. What if I do and TFTP? hit enter, and I can see my packets on the bottom, they disappeared. So now I'm being real specific. I'm saying everything to and from that device on this specific protocol, go ahead and apply it. That's a basic plain Jane one. You're going to do that all the time if you're working around in Wireshark.
Can you do or instead of and? Is that right?
Absolutely, you can. In fact, why don't we take just a quick little, I know neither one of us, David, are slide people, right? We really aren't. We're not much into PowerPoint slides, but I am going to show you one that is just going to help us to see a couple things here. Okay, so here's some common filters that you can use with Wireshark. So you saw the syntax for just a single address. Also where we can make it a source or a destination. Another one that I use a lot is going to be the address range. So you see IP.adder equals, and then you give it the address or you give it the network number. And you see I got my /24 there. So that's how I can denote an entire subnet. And that /24, going to the CCNP people, CCNA people, learning how those subnet masks work and the bit level filtering what we can do, we can give it any range. I could say 10.0.0.0/8. So I just want to see all the 10 addresses. So that's a nice one to use when we're not really specific on a specific address on its own. Maybe I want these 10 addresses. Any of those will do. So I can back up that subnet mask and I can adjust it accordingly. A couple other ones that I use quite a bit, port numbers. So we have TCP.port equals 80, or within the TCP protocol, I do a lot of flag filters. So tcp.flags.syn. These are some common ones, but as we're learning how filters go together, a nice thing about Wireshark is that it will help you. So if you mess up a filter, it's going to show red there. So back to your question about equals or one equal sign, that's not the proper syntax for our filter. So if I just put in one equals, it's going to show red. It's going to say, hey, Chris, you missed something here. Go review this. I didn't like it. And then when I get that syntax proper, then it'll show for me. Now to the operators. Here's some of the operators we need to use. Okay, so you can use either the top row or the middle row. So either the two equal symbols or the English EQ, or we can use, okay, if I want to say not, I can do exclamation point or the word not. The or, so it's a double pipe or the word or. 2 ampersands or the word and. Greater than symbol, GT, or less than LT. Notice below that, I have a filter here, and that's set. So IP.adder, and notice I say EQ, so that's the English, and then the IP. But then I use the symbols, ampersand, ampersand, TCP. I can use either one. It's all up to you. What's your style? Some people like to use all the English on the bottom. Some people like to use just symbols. Wireshark doesn't care. I kind of use a combo. I get my own style going, and then I just figure out and see what happens. All right, so those are some common filters. So let's go ahead and set some filters and use the Wireshark interface to help us to build it, because there might be some people out there thinking, okay, this is great, but I still don't know exactly how to build these filters. Let's go back into Wireshark.
So, Chris, is there a way that people can get hold of that, like PowerPoint, because it's a nice summary?
Oh, for sure. Absolutely. It's actually a part of a course that I have coming up. And it's going to be all about getting started with Wireshark. And those slides came from the section about Wireshark filtering and how we can build them and even save them into profiles and make more use of display filters. So coming to a Udemy near you.
So depending on when you're watching this, I'll have a link below, and you can get them as part of Chris's Udemy course. Chris, that's great.
Awesome. Okay, good. Now let's go ahead and go back into our PCAP. Let's make this practical, like down to earth. How do I really set filters? Now, I'm going to be honest, I'm not much of a typer. I don't like hammering them out, typing them out. It just, too much keystrokes and too much opportunity for me to mess it up. So what I like to do is I often will use some of the other features of Wireshark first. So let me show what I mean. I'll come up to statistics, for example, and come down to conversations. And then I'll take a look at TCP, for example. Now, a lot of times they'll send me a PCAP and they say, hey, look at this weird file transfer or check out this strange whatever. So what I can do from a high level is I can take a look here first. And I can say, all right, what IPs do I have? What is talking to what? What is it likely that they're wanting me to focus in on? I can sort the bytes column. I can jump back to the top here. Hey, this looks like a juicy little conversation, 65 kilobytes. Maybe that's the one they want. Let's right click there, apply as filter, selected, A to B, B to A, click. Boom, close. There's my filter. I just saved myself from needing to type out ip.adder == ampersand ampersand TCP port. You get the picture. It took the for tuple out of the statistics and it put it up here for me. There's my filter. Now this is a pop conversation. I can start to come through and now use some other aspects of Wireshark to do some further digging. All right, so right-click filtering. Just right-click. It's easier. I can even do that from here. I can just show you a little bit further. If I right-click a packet, I can come down to conversation filter, and now I give Wireshark the basis for the filter. Okay, so do I want the basis to be the MAC addresses? So is this going to be between these two MACs? I want to see everything going on. Is it between the IPs? So if I have several different TCP conversations on top of one IP conversation, I could say, hey, just show me the IP addresses. Or if I want to be specific to the TCP for tuple, which is the two IPs and the two ports, that's where I come down to TCP, and I could have set the same thing that way. Also, a very common filter. Those are things I think I do. I would almost say this is the one that I use the most, right? TCP conversation filters like that. Now, there's a few other ones that I also would suggest people know about and even save as a part of their profile. Okay, and I'm going to show you one of mine. If I come up here to over here on the top right, no doubt you noticed that there's quite a bit of buttons that I have up here. So what I can do is I can start to save filters. When I create a filter that I like, I can go, you know what? I never want to have to type that again. I want to come up here to plus, and I can name it, and then I can add it to my filter buttons. Now I'm going to cancel this one because that's an unlikely one that I need again. But if I come here to TCP connection, this is actually a menu that I created. I'm going to show you how to do that. And then I have all the buttons that are TCP connection filters under it. So you can see some of the ones that I have in this profile. Bad TCP. That's going to show me retransmissions, dupacks, TCP ACT unseen segment. You notice the filter that I use to get that? It's called tcp.analysis.flags, ampersand, not TCP analysis window update. So Wireshark natively, when it sees a TCP thing happening, like something bad, like a retransmission or a dupack or anything like you see here, it's going to flag it as a TCP analysis flag. It's going to say, hey, David, there's something wrong here. You should go check this out. That file's under TCP analysis flags. Now for me, window updates aren't necessarily a problem in of themselves in all cases. All that means, a TCP window update just means, hey, David, we're connected. So you're sending me data and I have room for 10,000 more bytes. Oh, wait, I just cleared out some data. I've got room for 12,000 bytes now. Oh, 13, right? If I update my window, then that means that I'm just telling you about more window size. That is a TCP window update. Now, for me, that's not going to be as like a critical problem. In fact, in Wireshark, we don't even paint it black and red. It's just and in fact, let me see real quick.
So you're looking at all flags, analysis flags, where something's gone wrong except that one. Is that right?
Correct.
Yeah.
Like here, I have one. You see this TCP window update? Let's actually investigate it real quick. Let's go on a little side tangent, shall we? Now this station, it ACT data above. So server was sending, looks like an email down to this station. Station said, thank you. Thanks for all that stuff, Mr. Server. I just clicked this packet and you can see on packet 239, there's my check mark. That means packet 240 is acknowledging everything up to 239. I'm good to there. Well, right after that, the client sends a TCP window update. So let's peek real quick at what that actually means, what it was doing. If I go to the packet previous, I'm going to come here to the TCP, going to come down here to window, and you can see this is 58,280. So that means it still has room for 58K more bytes. So if I take a look at the next packet down, the window size just went up to 64. So his buffer grew by a little bit, or rather his buffer was probably cleared out. So the application had data processed out of it, and he's now got room to accept more data. So that's why a window update, I don't usually focus too much in on that. If I come back to bad TCP, that's why I want to see all TCP events that are retransmissions, dupacks, things like that. So that's what that filter will catch for me. Okay, cool. So let's do this. We can probably even cut and paste this one down into the notes down below, but really all we do is we just pop that guy in, and then all you got to do is come over here to plus. And then to add it as a button, we could say TCP flags. All right. That alone as a button will be added to the top right. In fact, I'm going to go ahead and do that. I'm just going to say, okay. And you notice that we have TCP flags over here.
Yep.
Great. That just means if I remove this filter and I come back over here, TCP flags, wonderful. I never have to type that in again. Now I know about any TCP events, retransmissions. By the way, in the real world, David, if I see retransmissions and a bunch of dupacks and things like that, I start to hunt after packet loss. That means that TCP is having a hard time getting data across. If I come up to TCP flags and there's nothing here and it's clean and there's no retransmissions, dupacks, anything like that, then guess what? I say, hey, network guys, we're not dropping packets. Cool. It might not be the network.
Yeah.
We can start looking at latency and other things like that. But anyway, so I start to get real busy up here. So you know what I want to do? I'm just going to right click that TCP flags. I'm just going to say edit. And what I'm going to do is in front of this label, I'm going to come over here and I'm just going to say TCP con, okay, because that's the name of my menu up there, // Now Wireshark will nest TCP flags under the TCP con menu. And then I say, okay. So now I've doubled. I had one that said bad TCP and I have TCP flags. I'll remove that later. But anyway, this shows you how people can start to nest these filters. And if you notice some of the ones that I have up here, another common one that I use is TCP reset. I want to know when one side or the other aborts a connection. That's important to me. In this case, I know because I captured part of this PCAP. I know that I was doing a port scan with Nmap. So Nmap was just hitting on a lot of different ports that were closed, right? So those ports are coming back saying reset. But if I'm in an application environment and something that I'll listen for from my customers, if they say, Chris, it was really weird. We try to use this application and it just suddenly shuts down. Or I try to connect to that TLS server and it just won't connect. A lot of times things I'll look for are resets. That's a nice filter to have and not have to type it out. I just go to reset and there we go. All you got to do, everybody, tcp.flags.reset == 1. Let's go ahead and save that and then you can nest it if you choose to. Now, where do I get that reset from? Let me go ahead and talk about that for just a moment. In the TCP header, if I come down to flags, if I expand that out, the reset bit, if you look down in the lower left down here now, I got tcp.flags.reset. So here's another feature of Wireshark. Look, I'm not a filtering genius. I'm not a filtering genius.
That's what you say.
I don't need to be. Wireshark tells me all of the syntax right down there. So if I ever have anything in the packet at all that I want to filter for, if you see it here, you can filter for it. Any of this. Calculated window size. Look at that. tcp.window_size.
And just show us again, Chris, you can drag it to the top or can you just right click or something? How do you get it to that, into the top part of it?
How do I apply the filter up as a display filter?
Yep.
Okay, great question. So let's just say I wanted to filter on all packets that have a calculated window size of 0. If that's what I saw and I'm like, yep, that's what I want, I can right click it and pop it up to the display bar and I can just say, now it's going to ask me, it's going to say, hey, do you want to replace the filter that you already have? Do you want to and the filter that you already have? So do you want the filter and this? Or do you want the filter or this? Or do you want the filter and not this? Right? So it gives me some options. Let's go ahead and say selected just to replace it. And it automatically will apply that filter for me. So these are some of the features. Honestly, sometimes in some of my courses, people come in and they say, it's like, the filtering, it's just so hard to remember. and know what filters are useful? Well, keep in mind that Wireshark gives you these little hints. You always can find the syntax for any field in the lower left. And then like you just did, David, you can take an example of that field that you want to filter for, drag it up, and automatically that'll apply so you can see all the packets that meet that filter.
I think the problem is like, how do you know which filter to use for which problem? And that's where your experience really comes in. It's like what was your example? When people can't connect to something, then you look for resets, is that right?
Yeah, that might be, especially if it was like an abrupt thing. If they tell me like either disconnected or could not connect, something's blocking connection. My mind starts to go down, okay, reset. Or if you tell me it was slow in connecting, okay, so let's take a look at the handshake and let's see, do we get retransmissions? Are we starting to see that kind of thing? I have a couple other traces queued up for you, David, but those are the general ideas.
The great thing here is you taking your experience, and I was just discussing this earlier with someone else today, you taking what you don't get in a book and telling us when to use it. And that's a hard thing to do. Often books just show you the interface and they show you the switches, but they don't show you when it's valuable to use those switches.
Yeah, and for me too, like even in my trainings, if I don't use something, then I just tell you, forget it, act like it doesn't exist, move on. Because I can be honest in that I've never practically used that aspect, or I just don't use that type of thing.
Thing is, you do this day in and day out. So if you don't use it, there might be some edge cases, but for most people, it's not going to be that useful.
Or in some cases too, something else I ran into, a lot of people are in a certain place. They're in one network all the time, right? Yeah. So they might have that one application that's always running on port 13,470. And, and there might be some filters we can build for them there. But, for me, I'm jumping into different networks all the time, different applications, different environments, cloud, virtual, wireless, all kind of stuff. I just that's what I wanted the people to get from this session that we're having today, or here's some common filters themselves that I practically use, and also where I get it from. I just use Wireshark to help me build a cheat sheet. There's a few more I'd like to show you. What do you think?
Yeah, it'd be great. It's if you can give us the rationale of why the filter is used and then the filter itself, that's gold.
Okay, let's do this. I got one other type of filter that I want to make sure everybody's aware of. And so I showed you some basic ones. We looked at conversation. We looked at how to do a single IP filter, between two endpoints. We looked at a port number. But there's some special filters too that are used. I use personally quite a bit with Wireshark. And that's going to be these three. So we have the contains, matches, which would basically be the regex or the Perl compatible expressions. And then we have the in, which is a membership operator. Okay, so blah, blah, blah. What's all that mean? First of all, a lot of times when we're talking about a string, if we're looking for a string of actual text, okay, so let me flip back to my Wireshark here. All right, so if we're looking for a word, like an actual, if you see here in my Wireshark here, NTLMS, let's just say that was something that I was interested in looking for. Or here we go, desktop, right? So sometimes there's clear text in packets these days. And DNS, it's still there. There's a handful of other protocols. Even with TLS, in the client hello, we still have access to the website that we're trying to get to. So sometimes I can use that as a filter to try to trigger off of. But first I got to be able to find out where that syntax is, or where that string is in the PCAP. So to do that, what I can do is I can come up here to my display filter, and this is where I can start to apply this. I'm just going to do frame contains, and let's use this as an example, NTLMS, okay? Now contains is very specific. It's going to say, okay, anywhere in the frame, so starting from Ethernet, any packet that contains this string specifically, go ahead and show it. Okay, I only had 3 appear. Now, the reason why I like frame contains, and I've seen some people come in, they say IP contains, or TCP contains, or DNS contains. Well, I don't want to be overly specific. What if I want that string and, okay, it's likely IP that I'm using, but what if it's IPv6? Or what if it's another type of protocol? Well, regardless, I don't care what's contained within Ethernet. If you see these characters, show the frame. And that's how we can look for a specific word. If
if
I'm
you
just
captured on
looking for
another old link, it would still capture. It's not just Ethernet, is it? It's just like any layer 2, is that right?
whatever's in that frame, yeah. And I'm going to be honest with you, it's been a while since I've tinkered with not Ethernet 2, so
Exactly.
I'd have to test that. But yeah, if it can be decoded,
I'm showing my age here. Sorry, go on.
I'm sorry, David, we can't talk about Token Ring today. I'm sorry. But if I want to be specific to, like, let's just say DNS or HTTP, or this is where I could start to say, okay, I don't care about all the DNS. I want to know, do I have HTTP contains? So now looked at that protocol contains this string. That's one that I use as well. Now, let's flip this on its head a little bit. What if I wanted that string, but I don't know if it's capital N, if it's lowercase TLMS, I don't know if it's uppercase, lowercase. This is where I can come in and I can do frame matches. See, now it doesn't matter as far as it's not case sensitive, right?
So contains is case sensitive, yeah? Sorry.
Correct. Yeah, contains is case sensitive. Matches is not, because matches gets us into more of a free-flowing regex filter expression afterward. Okay, so this is honestly one that I use quite a bit practically when I'm looking for a specific type of string. And a lot of times, just to give you a practical example, Dave, so a couple of, I can't remember now, there was, I think it was the last one that we did, the Nmap one. We were talking about how to trigger on specific areas within a PCAP. Yeah. If you have like a lot of different PCAPs, right, and I want to find where the person hit this website, or they were going out and talking to this server. This is where what I can do is I can go in and I can set a frame matches, and then I can find where they hit that website. Now I have a bit of a context. I can widen around that, and I narrow down to a narrower part of traffic. That's the whole idea. I just want to narrow down the amount of packets that I'm dealing with to try to find that needle in the haystack a little quicker. Now, let me show you, while we're still trucking along with our filters, a lot of times I might be tinkering with an application that has more than one port. So say, for example, how about a web application that supports both HTTP and HTTPS? So here I can come in and I can say, okay, TCP port 80, but I also want, or TCP.port == 443. Okay, so that would give me both port 80, port 443. But it's also possible that they're using some other non-standard port for web. So what if they're using port 8000? Let me just do or TCP port 8000. You see how I'm using a lot of these same statements? I'm like TCP port this, TCP port this, TCP port this. This is where instead what I can do is save myself some typing. Okay, so here on this, for this filter, so instead of having this or this or this or, what I can do is I can come in here and I can say in TCP port in bracket 80, 443, 8000. Now I can give it a bunch of different parameters. I want this port or this port or this port or this port. I can even give it a range, ... 8004. So now this will show all applications or ports that match any of these or are in the range between 8000 and 8004. Honestly, this is one that I use quite a bit too.
And it's curly braces, yeah?
Yes, exactly. On each side.
I noticed something when you, on the previous one where you did the equals, you didn't, on some you had space and some you didn't have space. So when it's a operator like equals or something like that, the spacing isn't important, but it's important between the words, yeah?
That is correct, yes. So you were saying, okay, like
that,
80.
yeah.
I could have that or I can have the spaces. That's totally a style thing. Wireshark does not matter, it doesn't care. Okay, let's back up a second. We've learned how to do an IP address. We've learned how to do a conversation. We've learned a port number. We've learned how to look for a specific string, like a text value that's anywhere in a packet. Now let's use some of the features of Wireshark to start to find delays, lag. Like, can I build a filter that would show me slow? I mean, does that sound useful to you?
Oh yeah, that doesn't sound easy though.
Yeah, okay. Well, thankfully we got Wireshark. So I'm going to show you, there's several different time filters that Wireshark has built into it. You just got to know that they exist and then learn how to filter for them. So here on this PCAP, first thing I'm going to do, let's just go ahead and set our port 80 filter. In fact, you know what I'll do? Instead of port 80, I'm actually going to come back here and do HTTP. Now, what's the difference? Well, you notice that a lot of my green lines and red resets and all of that went away when I did HTTP. Now I've got the pertinent payload part. Ooh, 3 P's in a row. That's this is the actual application communicating. When I say TCP port 80, I'm asking for the handshakes, the ACKs, the resets, the fins, all the underlying TCP chatter, as well as what's being carried within that conversation. When I say HTTP, I'm like, okay, get rid of the transport layer. I don't need that handshake. I don't need all that stuff. Just give me the actual payload, the gets, the responses, the post, and so on. And that's what we can see over here. If I say HTTP, this is where I can come in, and you notice here that Wireshark is saying, okay, Chris, this packet here, 1122, goes with this packet, 1166. You see those arrows? Now I have a way to measure response time, but Wireshark helps me out. If I take a look at this second packet, let me look at the response, and then I can come down into my HTTP part of my packet. If I expand HTTP, you see time since request right there. Now, in those braces, in those brackets right there, anytime Wireshark presents information that's in those, that is a Wireshark derived value. This isn't actually a part of the HTTP protocol. This is Wireshark doing you a solid. Wireshark's like, hey, just so you know, that was 59 milliseconds. So, all right, now I'm out. Right. But the cool thing, check out this thing in the lower left, http.time. I can now filter on that. So check this out. http.time. Let's filter on that.
And this is your local machine time, isn't it? So it's like when it captured the first packet and then when it saw the response. Is that right?
This is from whatever captured it. Correct. Actually,
the capturing device, yeah.
Yeah, whatever capture device, when this packet came in, it got a timestamp. Boom. And now my machine is representing it according to that timestamp, and also considering if I have time of day like I have here, it's also considering my time zone, unless I have it set up with UTC. But that was a good question.
Yeah, so in other words, it's like you did the IOTA thing last time in our other video. You used like a little device to capture a whole bunch of traffic at Y speed, and then you take that off, and then you could have captured that, say, in the UK, or someone sent you a capture file from the UK, and then when you open up in Wireshark, it just changes the time zone, but the timing is based on that device that captured it in the UK, correct?
Correct. Actually, technically, it's based on second since 1970, January 1st. So,
but I mean, the time is based on, how do I say, the delays and stuff between the packets is based on that device that did the capture, which could be in the UK, but you were looking at it in the US, yeah?
Good man. So, so the time and place, when I capture, I'm bringing traffic in and I give it a timestamp. And that timestamp is universal. If I'm capturing this, if I'm looking at it if I'm in the United States, for example, if I'm capturing at 10 a.m. and I say, hey, David, check this out, and you're in New York, and I email it to you, it's going to look like it was captured at 1 p.m.
Okay, so it adjusts it, yeah.
If you have time of day here, not UTC. If you wanted to see what I saw, then you would come up to View, Time Display Format, UTC.
Yeah, so that's important because, in other words, if you start sending stuff across time zones, you've got to remember to set it to the time zone of the place that did the capture. Otherwise, it messes with your brain, doesn't it? Because I could send you a capture and it could be the following day. Well, you send me a capture. You could send it in your evening, and to me, it's the next day. Yeah, that kind of thing.
Yeah. So it gets a universal timestamp, and that's a great point. Sometimes I'll be teaching my classes, and I have people from India, from the UK. I've got people from South Africa, and from the United States, all in my Zoom.
Yeah. And
I say, all right, everybody, let's open up a PCAP. And if everyone has time of day, everyone's going to see something different.
And that's the default.
I say the default is actually second since beginning of capture. That's where we start a stopwatch, and it shows us when a packet came in. But if I want to see, for example, what time of day did something come in, that's where I can come into View, Time Display Format, Time of Day. Or if I just want everybody to be on UTC, so what I'll do is I'll tell the students in my course, all right, everybody, go UTC. So we're on the same time reference.
Yeah, otherwise it gets confusing, yeah.
Oh, yeah. And that was a good point. Good catch. But this time, HTTP time is not telling us the time of day. What it's telling us, if I come down here, it's time since request. So this is, I start a stopwatch on the request, and I stop a stopwatch on the response. So this is an HTTP response. So let's go ahead and do this. Let me, okay, I've already brought HTTP time up here, but what I want to do, I'm actually going to right click this, and I'm going to apply this guy as a column just to take a look at it. And here I can see for this entire PCAP, how long did it take for those responses to come back from the server? So this is application response time. Wireshark's already measuring this for me. So let's just say that I'm in a data center and typical application response time from a web server is, let's just take a look at this. Okay, 25 milliseconds or less, okay? I expect to see 25 milliseconds or less. And I want Wireshark to tell me, are any of them longer than 25 milliseconds or slower? So I can take HTTP time and I could say, show me HTTP time that is greater than .025. That's 25 milliseconds. Enter. I've got two that were slower than 25 milliseconds. I can now save that as a button and I can call that slow HTTP. Now you might be thinking 25 milliseconds, big deal. 25 milliseconds, that's nothing. Well, that's why I've got another trace file for you.
I just wanted, before you go there, Chris, can you, like real world, which time do you typically use? Like in your class, you said everyone to UTC. That makes sense because you've got our students in different time zones and it would be like really confusing to try and get people to look through the PCAPs. But like when you're doing this, the person just sends you the PCAP and then what time do you use to keep sanity?
Depending on the type of application, one that I use quite a bit is going to be TCP Delta time. And I'm building to show you that one.
Okay.
This is the easiest way to show you with HTTP, but that's a great question. If I start to see long delays coming back from servers that are, more than, I start to think in terms of what would a human being actually observe, right? You and I don't really know what 0.025 is. But we do know what 1 second is. We start to know a lot if we experience 1 second a lot of times. So I think, about half a second if I start to see anything longer than that. But if everything around it is 50 milliseconds, half a second is 10 times longer. So that's where, for me, I'll take a filter like this and then I'll just be up here and I'll start to play with these numbers, right? I'll start to adjust it and I'll go, let's take a look at, okay, is anything 100 milliseconds? No, okay, all right. So that's where I can start to move these filter numbers around to fit into that troubleshooting exercises that I'm up to. But are you ready to see one? Okay, what's the standard complaint as network engineers? You and I are network engineers. What do we hear all the time?
Yeah, network's too slow.
Yeah, exactly. Okay, so let me bring this up, this next
It's always
one.
our fault, Chris.
I know, right? Yeah. And then exactly. We
guilty until proven innocent, yeah.
So you ready to see one where the network was slow? All right, everybody, join me on a consulting opportunity. Is everybody ready? Okay.
Yeah. How much do we get paid?
You're going to be, oh man, you get paid.
Nothing.
Right, nothing. But you're going to have a good time with me and David Bomball. I mean, is that not reason enough to stick around?
Definitely.
Okay. You're the consultant. And your client, your customer said, hey, we're getting just beat up by the application people. They're like, boom, 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 saying your network's terrible. Your network's awful, blah, blah, blah. And they're like, you know what? I don't think it's the network. I just don't exactly know how to prove it. But we bring up Wireshark and we see these black lines with these red letters and we're like, oh no, the sky's falling. The network's being ripped apart at the seams. So let's actually see what's really going on. So this was a PCAP, and the complaint was that the network was slow. And of course, they put out a bid to upgrade everything, to go from 1 gig to 10 gig, and go from this ISP to the other ISP, and upgrade their bandwidth, and upgrade and upgrade and upgrade. Because what do you do when you have a problem? You just throw a bunch of money at it with no facts,
So this is from a real client, yeah, that you had?
Yeah, absolutely. Yeah. And this is used with permission. And as well, if you notice over here, packet size limited, what I do is I can cut the payload out. So all you see is the headers. Actually, it's a good time to mention this to people. If you see down here on the bottom, like look at this packet, you see it says 14 bytes on wire, but 90 bytes is captured. So what I did is I used a tool from a buddy of mine named Jasper. He's an amazing analyst. He wrote an application called Trace Wrangler. Definitely got to link that one down below. But what it does is it allows you to change addresses and cut out payloads. It just anonymizes a PCAP. Yeah, it's a great tool. And thanks, Jasper. You're awesome. He's a fantastic analyst too. Okay. So SYN, SYNAC, ACK. What have we learned in those three packets? What's our network round trip time? There's our 97 milliseconds, right? All right, so SYN, SYNAC, ACK. Our network round trip time is 97 milliseconds. All right, I'm going to store that away. What have I learned so far? I got to the server. He responded. He's got room for a new connection. I'm saying, great, thanks. So my three-way handshake completed. By the way, I'm going to come up here to view time display format, seconds since beginning of capture, just to kind of start the stopwatch. All right, handshake is successful. Client sends get to server. Hey, give me this. And there was so much data. There was a cookie and stuff in that request. It was so big that it actually spanned more than one packet. So we filled one that was 1460, and then we had some residual traffic that went on to the next packet. All right? So 2 packet requests. These just get fired off. So far right now, let me ask you, David, if you started an application and you were 104 milliseconds in, would you be punching your screen yet? Is it slow?
Mm-hmm. Maybe. Probably.
Yeah. Right. Yeah, maybe.
Depends if I'm depends where I am in the world. Yeah.
Yeah, right. Okay. That's a good, well said. But usually as humans, 140 milliseconds, we're not too punchy just yet. We're pretty expectant, but that's still pretty quick. Packet 6. I know my packets got there because packet 6, if we look down into our sequence and acknowledgement numbers, by the way, tune in for TCP Deep Dive Part 2, where we're going to be going deeper into the sequence number and acknowledgement number, ladies and gentlemen. Coming down to acknowledgement number, my get got there. Received. It's just like when you call up into a call center and you say, hey, how you doing? Can I check that flight? And they're like, please hold. And then you say, okay, I'm just going to hold. I'm just going to sit here listening to the hold music. So 45 seconds later.
Oh, wow. I didn't see 45 seconds. Yeah. Okay. That's not too long.
Right. 45 seconds later, is it the server or the client? If I head check up here, clients start connections. They initiate the SYNs. The client is the one. 45 seconds later is like, cool. Server, we still good? Did you disappear? Server comes back 99 milliseconds later, which is the network round trip time. You see 99 milliseconds, 106 milliseconds, 97 milliseconds. Those are things that my eyes look for, everybody. When I'm troubleshooting, I want to see, do I see any drift? Do I see a big drift in round trip latency? Does this go up to 500 milliseconds or 300 milliseconds? No, it's right around 100 milliseconds. The network latency doesn't change. So my stuff's getting there. ACKs are getting back. Server's like, please hold. And then I'm like, okay, great. I wait another whopping 45 seconds. See, what's happening here, the TCP stack on the client wants to shut down. If I perceive that you're gone for too long, like, hey, look, I got other stuff to get to. I got to free this port up. So if we're not connected anymore, I got to move on. That's why it's going to try to keep it alive. Like it's going to say, hey, keep alive. And if you don't respond to this keep alive, then I know, okay, I can do a reset. You disappeared. You left the building. But your stack comes back and says, we're still going. That means the applications haven't let go of that TCP connection yet. That state is still being maintained. Packet 9, we do it again. We say, keep alive. Server comes back, yep, I'm still here. And check this out. This just when I saw this, 18 seconds after the second keep alive, the server comes back saying, here you go. Okay, here's your stuff. 15, 18 bytes.
So what is that? Like a minute later, over a minute later, they got their piece of data, yeah?
Well, let's go down and see time since request. You see time since request?
There you go, nicely, yeah.
We waited 108 seconds for this application to begin responding. TCP was just doing its job, keeping the connection open. The network could have done nothing else. You're talking about light speed, network round trip time of 100 milliseconds. There's zero amount of upgrading on the network that would have improved this.
Tell me, Chris, how much money were they going to spend before you got involved, or was it just that they got involved?
Look, I just go over and ask him. I just pull my pocket out and I'm just like, could you just put the money here instead? Because that's more than I'm going to make on this consulting thing anyway. But no, I've seen, honestly, I've seen people, I don't even like to say it, but I've seen one customer dump $1 million into fixing something like this. Because once you start talking big box upgrades, and and then the sales guys get involved, and it's like, well, you're at Cat 5e, you should go to 6, or you're at 6 and you should go to 6, whatever. It's like then you start upgrading things that frankly won't have any impact on the performance.
So it's just nice to have war stories. So you've got involved in situations like this where we're talking like $1 million or whatever crazy money, and you basically saved the business the money because you could find something like this. Is that right?
Absolutely. But here's the problem. A lot of times they don't call me until they've already spent it, and then it didn't work. And then the manager's really mad and he says, we got to fix this, and that's where we don't want to blindly just carte blanche upgrade things without having basis that it's going to actually work. Right? And that's what packets can help us to do. So here in this case, we could have upgraded the network to Kingdom Come, but it wouldn't have adjusted or it wouldn't have improved our latency. So what we had to do is we had to move our point of analysis to the server side. This is about all we can get from the client side, right? Because the client just doesn't see what else is going on. So now we got to go, okay, on the server side, I see requests coming in. What is that server doing next? Is it talking to some backend system that doesn't exist anymore? Is it just going back to some SQL box and it's just hammering that SQL box and that's really the cause of the end slowness? But here's what burns me up. So in this case, this is a war story. A lot of times IT organizations are large organizations with different cost centers and payment methods and such. Well, the network guys, they brought me in to do this analysis to basically, we proved it wasn't the network, but then we tried to get authorization to do some packet captures on the server side and we never did. So anyway, I never got to know where that 108 seconds was going. But check this out. If I take that time since request, going back to filters, and if I say now, okay, time since request, let's do this. Let's just do http.time is greater than, how about 1 second? That sounds bad. Show me any time you have a request that takes longer than 1 second to come back. Here I found, and I can come down here and I can actually add this as a column. And here, time since request. Check out the response times from this server. I had 108 seconds, which was the first one. Then one after it was like 4.5 seconds. Then another was 4.7, then 30. And I said, so am I getting the right picture? When your employees sit down to try to load this application, they are legitimately waiting 3 minutes for this thing to actually start being, up to 3 minutes. And they said, yeah, we start the browser and we sit there for 3 minutes and then it populates and then things are good.
That's mad.
And it's the network.
Of course it's the network.
Yeah, crazy, huh? So with something like HTTP time, this is a great way to get an idea of application response. Now,
you could do that for other applications. Sorry, Chris, to interrupt. That could be FTP, whatever it is, yeah? Whatever app's giving problems, just do that on a capture on a client, and that will allow you to see if it's TCP or if it's an application. Well, it helps you break it down, doesn't it?
Yes. So let me clarify that statement just a bit. It's not for every application. Wireshark needs to be able to interpret that there was a request in the dissector like it just did for HTTP. So it knows what gets are and it knows what posts are. And then when it sees a response code, it can merge those together. It knows this time or this request went for that request. This response went for that request. So it can do this for DNS. It can do it for HTTP. It can do it for a handful of other applications. But just because we can do it for those doesn't mean we can do it for everything. So,
but the big one, HTTPS, though.
right. So HTTPS, we don't know what the request was, so we can't add the response in. But that doesn't mean that we're completely in trouble. You want me to show you what I do in those scenarios?
Yeah, I think for a lot of people, I mean, I want to get that is like real world. A lot of apps use HTTPS today. It's great to see it in HTTP, but how on earth would I do that with HTTPS?
Okay, David, so I'm glad you asked about the HTTPS because that's just the reality of what we're in now, right? So secure applications, we don't have a get string that we can filter on with a response. So what I'm left to do in those scenarios, and I'll go ahead and take a look at this PCAP with you. This is an example of just a simple TCP thread. And what I'll do is I come in here and I'm interested in, for example, I'm just taking a little walk down here. Oh, by the way, at the end I have quick, which is a whole nother animal. We'll save that for another conversation. What Wireshark is able to do is it's able to make measurements based on not just the application, but it can also do it for TCP. Now, in this case, I just have a single TCP thread. But if I come down into TCP, let's check out some of the timers that it can find. You notice below options, I have timestamps. I'm going to expand that. I've got time since first frame in this TCP stream. And this is the important one. Time since previous frame in this TCP stream. Right click, add as column. Why? Because when I have multiple TCP connections going in parallel, like in a real network, this is what you'll have. You'll have a lot of different TCP streams, and they're not nice filtered connections like you see in a lot of my PCAPs that I use for demonstration. In a real environment, I want to see TCP delta because that considers the context. So I can have 9 TCP streams. All of them are going all over the place. But this counter is going to show me what was the time from this packet to the previous one that was in this conversation, which delta time will only show me between this packet and the one immediately before it, whether it was a part of the conversation or not.
And it groups it together, does it?
TCP delta will be in context. Yeah. Is that what you meant by grouping?
Yeah. So like, in other words, it's not all jumbled up. You don't see all the sessions together. Like I see a line on the left-hand side. Is that like it's grouped them together? So you get the one conversation.
Yes. Yeah, good spot. So when I have, in this case, I have a single thread. So all of these are a part of the same thread. But if I had several going in parallel, and maybe we'll do that on another video, where I'll see this line, but it'll break up where I'm on a packet that is not involved. Yeah. But TCP delta is an important thing. In fact, if I come down, I can even now filter on this. You see down below in the lower left, TCP.time_delta. Now that's something I can filter for. So I can come up to the top and I can say TCP.time_delta is greater than, let's just say 100 milliseconds. Now I see all of the hiccups in that thread, even in a secure conversation. This is what my eyes do. I look at that first packet. This is from the client. The client is taking almost 2 seconds to change its cipher spec and continue with some application data. Note to self, the second one, this is from the application, taking time to get back to us. So to be honest, between the two of these, it would be more concerning to me. This would be the one that I don't like to see server delay. Client delay, sometimes you'll see just when the client is entering in a password or just slow to go up and click on a bar. Boom, that's called client think time, client delay. In this specific case, I might want to look a little closer. Why is it taking the client so long to do that? But usually, in most cases, I'm going to look for this server delay. Let's go ahead and remove our, by the way, save this as a button. Call it TCP delay, put it under TCP connection. I'm going to make sure everybody got to know how to do that. This is a live class, you know. Okay.
At some point, I'm going to have to you're going to have to like go through all those little buttons you've got there and give us the ones that you've created.
Oh man, we haven't even gotten to signatures and weird country codes and yeah. So, all right. So, but your question was, how do I do this with secure web? How do I troubleshoot in a secure environment looking for delays? Well, here's one of them. Look at the context. Around, I've got 20 milliseconds, 24 milliseconds, 24 milliseconds, 265. This is 10 times longer. And this is waiting for the server to come back with data. This is an example of something that would catch my attention if I was in a secure environment, even though I can't see the application request, I can still see the packets and the direction they're going in. I see a big packet go to a server. I see an ACK come back that's empty. That means the server got it. Then I time how long it takes for that server to begin responding. I don't care what the data is. I know it's not the network.
It's a pity that they didn't give you like half the money they saved, Chris.
That is a pity. I mean, come on, man.
Yeah, but it's sad, like you say, they spend the money and then they get you involved rather than doing it the other way around. But sorry, you wanted to say something.
No, I was going to ask the audience. Hey guys, comment below. Do you want to do like a war stories thing? That would be fun.
That'd be great.
I've got a lot of different examples that would be fun to walk you guys through in some practical real life scenarios.
I think the audience, let us know. But I think, Chris, if you can give us like a war story and what would have been a better way to do it or how you save money, that would be great. Like practical stuff. Yeah, definitely.
Saving money with packets. I can see it now.
Yeah.
Yeah, so back to filters. Let me just see if there's any other ones that I haven't shown you yet. I'm just going to breeze through my buttons here. Slow IRTT. This is one that I use. In this PCAP, it doesn't flag anything, but we can see what's behind this filter. TCP.analysis.initial, RTT means round trip time, is greater than 1 second. So I want to know basically that initial handshake, that initial TCP three-way handshake, is that taking any longer than 1 second? If it does, network latency, what's going on? We got to take a look at why it's so slow.
That would be a network problem.
I would look there first. Yeah. Like what's going on? Congestion, slow stuff. Also DNS.time. So also everybody can use that as well. So DNS.time, if I have a DNS response that's taking longer than a second, this number is always like a full second, right? So I could do 0.1 would be 100 milliseconds, 0.01 would be 10 milliseconds. So just depending on your environment, what's normal and how far do we want to drift from normal before we start to hit this filter? Tinkering. I'd be in trouble if I didn't show you guys how we can simplify our PCAPs. Honestly, so I get into an example. Someone sends me a PCAP and they go, "Oh, I don't know what's going on. Here's the IP of the client," and I can go, "Okay." So I don't know a lot about what to filter for first. Okay, so if you're sitting back going, "Okay, I see how to build a filter. I just don't know which one to use." Well, you're not alone. I feel that way too sometimes. So what I do is I start out by going, you know what? I don't know what it is exactly that I'm looking for just yet, but I know what I'm not looking for. I know that there's things that I can scoop out of this PCAP to make it smaller. For example, what if the application that I was troubleshooting here was not over TCP? What if it was over UDP? So I could say, no TCP. Get out of my way. Oh, it's over quick. Okay, at least I was able to cut down my PCAP. All right, let me show you the one that I use actually quite a bit as far as removing things that I know are not involved. So I do, not, open parenthesis, and then something honestly like ARP. Okay, if I can see that ARP is working well, get it out of the way. And then if I have a bunch of stuff on the network like STP, so spanning tree updates. Okay, the spanning tree is doing its thing. All right, get out of my way. Or CDP. Okay, wonderful. We can see our link neighbors and so on. Get out of my way. I'm not interested in you. Or whatever it is, I can start to fill this out. Or LLDP or ETH adder equals. You can probably guess what I'm starting to build now. FF. Get out of my way. Now I have a way of just scooping that stuff out to simplify my filter. I'm still not sure exactly what it is, but at least I can get some of this noise out of the way.
That's a problem. It's all the noise, all those other packets that you've got.
Yeah. And in some environments, that's a significant amount of traffic. So at least that gives me what's left over. And then I can start to come through, okay, this conversation, this DNS, and so on. I call this just I believe that I have this under no broadcast chatter.
I like that, yeah.
I just say, just
so
get out of here.
Is that exactly the same as you just built? Yeah. Oh, there you go. Yeah.
Except for ICMP. And then as I learn more, I'll just add stuff to it. Like this is where I could say, or in this case, you know what? I'm not even looking for TCP. Let's get on my quick. right? So the idea is I really want to just simplify these PCAPs to get them to be as simple as I can, and then I can dig through and start using these filters to really try to find stuff. Now, as far as while we're still on filters, maybe just to wrap up, signatures. What I do, and on this profile, I don't have a ton of them, but I have a security profile with a lot more. What I did is I honestly just started studying Suricata and Snort signatures, and I started building Wireshark filters based on those IDS signatures. And that way, what I could do is I could start just ripping through here and, okay, weird TTLs. Like this one is a TTL that's less than 50 or greater than 30. The reason is because if I have a TTL that's in that range, well, it probably started at 64. That means I'm dealing with a network that is more than 15 hops away. And it's just in this weird band where it could be fabricated, right? Because a lot of times I'm not dealing with networks that I'm 25 hops away anymore. A lot of times I'm usually comfortably within the 10 to 15 hop range or less. This might be something I want to check out. I think I got that from a Suricata signature. Country code, I could have USA, Russia, UK. Yeah, Russia. That's a Russian country code if I want to see any traffic coming over from there. There's some dodgy place over here. So those guys, they're up to no good. That's how you catch all the David traffic, everybody. Just do GIP country GB, and that's probably David talking to you. A TCP SYN with no options. That's weird. So here I have a TCP flag. It's going out, and the TCP header length is 20. Super unusual. I should see TCP options. You guys remember that from the TCP deep dive. I should see MSS. I should see window size. I should see timestamps. I should see that stuff. So if I see a SYN with no options, no way. Nah, that's not good.
That's an Nmap or something, yeah?
That could be. I've seen that from Nmap, and I've also seen it on a true scan, some scan activity, and there was just no options in there. I'm not sure if they were using that tool or a different one. But yeah, but either way, I know that's not coming from something real. Yeah, so hopefully, just to kind of recap a little bit, hopefully this doesn't overwhelm anyone, but we started simple with those IP filters, the conversation filters, the TCP port filters, and then we pivoted more into some of the performance filters. So like HTTP time, DNS time, Delta, TCP Delta time. Those are great filters to use. And then we wrapped up at the end here with some security filters that I like to use, where we're almost acting like an IDS at this point, just using signatures to try to see if we can find any weird traffic.
So Chris, you said we could perhaps do a deep dive on performance, yeah, like slow networks. I think that's going to be a great topic to do.
Yeah, absolutely. And honestly, I have a lot of examples of that because that's what I get called to do. In fact, maybe I can tease everyone with this one. I have one where they were literally getting ready to just gut replace the network because things were so horribly slow. And it came down to one little mini configuration. And I'll show you what we found in the packets.
No, that's a good teaser. Chris, really want to thank you for your time. And I'm really looking forward to that because now you've made me very curious to know what that's about. But yeah, thanks so much for sharing your knowledge. You know, this is like years and years of experience that you're sharing here. So thanks for doing that.
Hey, I have a lot of fun doing it. So thank you for having me on again, David, and appreciate everyone that watched. And please let us know how you liked it and what you want to see.
Brilliant, Chris. Thanks. Cheers.